Hi, so for this video, I'll be discussing about linear inequalities in one variable with focus on solving linear absolute value inequalities. So let us recall first the definition of absolute value. The absolute value of x, written as you have two bars there and an x in the middle, represent the distance between x and 0 on a number line. Now the equation absolute value of x has two solutions. X is equal to a and x is equal to negative a. Let's recall that when we study absolute value, right, when we try to get, like for example, the absolute value of 4, of course it's a 4. And if you have like the absolute value of a negative 4, it would still be a 4. So sometimes whenever I explain to a student, I said that when we try to get the absolute value of a certain number, we kind of disregard the sign. Since by definition, the absolute value is a distance, right? And we measure distance always in positive. Okay, so this time let's have the rules in solving linear absolute value inequalities. Now, the first step is to isolate the absolute value. So before you follow the rules, we have 8 rules. Okay, so before you follow that, make sure to isolate your absolute value. You can do that by making sure that you only have the absolute value on one side of your inequality. All the others should be transposed or moved to the other side of your inequality. So we'll have examples of that later. Then let's have the rules then. So the first one is if the absolute value is less than 0, there is no solution. We all know that the absolute value of any number is positive, so meaning greater than or equal to 0. So if your inequality, okay, is less than 0, so we know for sure it's no solution. Let's have the second one. So if the absolute value is less than or equal to 0, there is one solution. Solve by making it equal to 0. So this is connected with rule A. So if it's less than 0, right, there is no solution. So if you have less than or equal, so we can find the value of x that is equal to 0 then and include that with our solution. And then the third one, if the absolute value is greater than or equal to 0, the solution, of course, is all real numbers. And then the fourth one, if the absolute value is greater than 0, the solution is all real numbers except for the value which makes it equal to 0. So this is connected with rule C. So it's all real numbers if you have greater than or equal to 0. So if it's just greater than 0, we need to remove the solution that is part of when x is equal to 0. So we will stop here first. Cut the rules for the first 4 rules, and then we'll have examples of this, and then later we will continue with the 5th until the 8th rule. So let's have examples. Okay, let's have examples. So let's say let's have the first example. We have absolute value of 4x minus 5 is greater than or equal to 0. So again, check whether the absolute you only have an absolute value on one side before you follow the rule. So here, yes. So we have absolute value one side and then all the others on the other side. Now, next, check the inequality that you have. So you have here greater than or equal, and the number is 0. So if you have um, greater than or equal to 0, you will be following rule C. Okay, so if you can still remember the rules that we have learned. So based from rule C, if you have greater than or equal to 0, the solution of your absolute value is all real numbers. Okay, so that you won't be solving much. Let's have another example. So we will make it similar, almost similar with the first example. So let's use 4x, absolute value of 4x minus 5. But this time we'll have greater than 0. So again, take note of that one. You have greater than 0. So if you have greater than 0, you'll be following rule D. So it says there that if you have like that, you need to make your absolute value be equal to 0, and that value is the one that you should not include in your solution. So what I will do is, let's copy whatever is inside your absolute value sign, 4x minus 5. So since we're looking for the value of x that we will not include in our solution, I will put a not equal sign there, and then 0. And then let's solve for x. So this would be 4x is not equal to transpose negative 5 to the other side. That would be 5. And then divide both sides by 4. You will have x is not equal to 4 over 5. So how are you going to write your answer there? So our answer will be, our solution will be all real numbers except when your x is 4 over 5, or you can just write it by symbol like that. But x should not be equal to 4 over 5. Okay, let's have another example. Again, I will use absolute value of 4x minus 5 so you can differentiate them. And this time I will have less than 0. So if you have less than 0, you will be following rule A. Okay, and based from rule A, if you have your absolute value less than 0, your solution is no solution. Okay, let's have last example for this. So again, I'll use 4x minus 5. But this time the inequality that I will use is less than or equal to 0. So this is somewhat related to example number 2, right? Where this time we added, just like the opposite, we added an equal to our given inequality. So this one, if you have less than or equal to 0, you need to follow rule B. Okay, and based from rule B, if you have something like this, all you need to do is to make your absolute value be equal to 0. So let's do that. So copy what's inside your absolute value sign, which is 4x minus 5, and again make it equal to 0. Then solve for x. So you will have 4x transpose 5 to the other side. Then divide both sides by 4. You will have x is 4 over 5. And that would be your answer or your solution for this inequality. Okay, now let's have the last 4 rules. So the fifth one, this is the fifth one. If the absolute value is less than or equal to a negative number, there is no solution. Okay. Next one. If the absolute value is greater than or equal to a negative number, the solution is all real numbers. Okay. That's kind of simply easier to remember. Then the seventh rule or rule G, if the absolute value is less than or equal to a positive number. So if your absolute, let's say we have absolute value of u, okay, if it's less than a and your a is greater than 0, meaning positive, then the solution of your inequality is that u is greater than negative a but less than a. We'll have examples of this later. And the last one is if the absolute value is greater than or greater than or equal to a positive number, or let's say that if the absolute value of u is greater than a and that your a is greater than 0, then your u is greater than a, or u is less than negative a. Okay, so let's use that one. Okay, let's have some examples. Okay, say we have three absolute value 5x plus 2 minus 1 is less than 14. Okay, so again, reminder that before you follow the rule, make sure to isolate first your absolute value. Okay, so to do that, so let's transpose negative 1 to the other side. So this would become 3 times the absolute value of 5x plus 2. And we will transpose negative 1 to the other side. So that would be 14 plus 1, which is 15. Next, let's divide both sides by 3 so that we can cancel the 3 outside your absolute value sign. So this would become absolute value of 5x plus 2 is less than 15 divided by 3, which is 5. Okay, so now you can check now which rule should you follow. So we have here less than 5 or less than a positive number. And if we go back with the list of rules, you should follow rule G. Let's recall what rule G is all about. So it says there that if you have the absolute value of u, for example, and u is less than a, and a is greater than 0, meaning it's positive, then the solution of your inequality would be in the form um, u is greater than negative a but less than a. So we will follow this format here. So let's do that. So let's copy the uh, one inside your inequality absolute value sign. So this would be 5x plus 2. Copy the inequality sign. Then our a is 5. So let's write 5 here. And then on the other side should be negative a. So this is negative 5. Okay, after you do that, you need to simplify your compound inequality. So let's remove positive 2 here. So you need to subtract minus 2 on all sides of your compound inequality so that we can cancel out this. You will only have 5x in the middle. And then this would become 5 minus 2. So that is 3 on the other side, negative 5 minus 2. That is negative 7. Next is to divide uh, all sides by 5. So we can cancel this one out. And now the compound inequality is already simplified. You have x is greater than negative 7 over 5 but less than 3 over 5. And that is the solution of your given inequality. Let's have another example. Let's say we have negative 2 times the absolute value of 3x plus 7 is greater than equal to 4. Okay, so again, do not go straight looking for the rule. Isolate first your absolute value. So here we still have negative 2, right? So let's divide both sides by negative 2. So this side here will only have 3x plus 7, and that's what we want. Okay. And of course, 4 divided by negative 2, that is negative 2. So remember that we divide by a negative number, and whenever we do that, you need to reverse your inequality. So you should have less than or equal to negative 2. Now, once we have this, you can go straight think of what rule should you follow. You have a less than or equal to a negative number. And if you have like that, you need to follow rule E. And based from rule E, if you have less than or equal to a negative number, the solution of your inequality is no solution. Okay, let's have more examples. Let's have the third example. Okay, say we have 4 times the absolute value of 2x minus 1 minus 10 is greater than negative 2. So again, let's isolate first the absolute value. So let's transpose negative 10 to the other side. So that would be negative 2 plus 10. So we will only have now 4 times the absolute value of 2x minus 1 is greater than negative 2 plus 10, which is 8. Next, let's divide both sides by 4. So this one will only be 2x minus 1. And then 8 divided by 4, that is 2. So now we can look for the rule that fits this. So we have here greater than 2 or greater than a positive number. And whenever you have this, you need to follow rule H. So let's review first rule H. So it says there that if, let's say you have the absolute value of u, and u is greater than a, take note that a should be greater than 0. So here we have 2, right? So therefore, you will write the solution of your inequality in this format. You will have that your u is greater than a, or your u is less than negative a. So let's follow this format here. So our u here is 2x minus 1. So let's write that. You have 2x minus 1 should be greater than a. Our a here is 2. So let's copy that. Or you have you again 2x minus 1. This time we will have less than negative a. So our a is 2, so that would be negative 2. Then let's just simplify this one. So this is 2x transpose negative 1 to the other side. So that would be plus 1. You will have a 3. So this would be x is greater than 3 over 2. The other one we have 2x is less than negative 2 plus 1. That would be negative 1. Divide both sides by 2. You will have x is less than negative 1/2. So our final answer is that your x is greater than 3 over 2, or your x is less than negative 1/2. Okay, so that's it for this video. Thank you for watching. I hope you learned something. Bye.